Hello everyone. My name is Lodan, and I'm a PhD student at IMT Authentic School. Uh, it's my pleasure to have this opportunity to attending this conference and have the opportunity to do the presentation to everyone. My conference topic is a digital twin driven methodology for material resource uh, planning under uncertainties. Today, I will introduce my conference paper according to these 4 points. First is the introduction, my conference paper, and my research work of the PhD is based on an European funded assistance project. This project aims to create intelligent digital twins between the joint use of machine learning, optimization, simulation, and domain models. And my conference paper and my PhD thesis aims to develop an intelligent digital twin for production planning to help production managers operate a smart factory. And the main target of this conference paper is to develop an intelligent digital twin for MRP. And first, I will introduce the literature review about the main technologies of Industry 4.0 used in material resource planning. We focus on these technologies, cloud manufacturing, digital twin, cyber physical system, Internet of Things, and the big data and analysis. About these frontier technologies, we found three main challenges. First is that the relationship between different systems are complex to integrate. The relationship include the relationships inside the physical systems, and the relationship inside the virtual systems, and the relationship between physical system and the virtual systems. And the second challenge is that the massive data creates new opportunities and challenges to make an effective production plan with frontier technologies. And the third one is that how to use frontier technologies to provide the dynamic and automatic support of production planning for the managers. And also about the challenges of stochastic optimization, what we will focus on the MRP systems. We also found the three main challenges. The first one is that the uncertainties of manufacturing environment. For the MRP, we must to consider several uncertain parameters at the same time in the real factory. But now the research we have do the literature review, we found now the research always focus on only one or two uncertain parameters. A few research focus on several uncertain parameters at the same time. And the third challenge is that the manufacturing environment is very complex, and it is difficult for mathematical model to represent and describe the production system precisely. And the third one is that we need to use algorithm to solve the large-scale problem, but now we still face many difficulties to solve the large-scale problem. For these challenges, we focus on the problem. The problem is the multi-column, multi-item capacity load sizing problem with uncertainties. And we will create a mathematical model of the decision problem and use and give the solution to get the production plan. For this problem, the input include the bill of material, lead times, demands, and the production capacities, and the cost parameters. And the objective is to minimize expected case cost. And for the output is that we will get when to produce and the size of production loads. For this problem, we give the solution approach. It's the digital twin-driven integration scans. First, we can use the Internet of Things to collect information and data from physical system into information system. And through this way, we can create a domain model. Domain model can provide data for different models, such as simulation models and machine learning model and the mathematical model. And first, we can gauge the uncertain parameters from the domain model or the simulation model, and using machine learning tool to gauge the distribution of uncertainties. And then we will create the generic mathematical model and use stochastic optimization method to get the production plan. And the production plan can be the input of production scheduling. And we will introduce the machine learning tool and the generic mathematical model and the stochastic optimization point by point. First is the generic mathematical model. The objective of the problem is to determine the suggested production plan, including when to produce, how many items to produce, and when to buy materials, and how many items to buy, and the amount of extra capacity required. And for the different systems, we want to give the same generic mathematical model. And this model can apply to different industries. And in this model, we have give some constraints, such as the constraint that can ensure the balance of flow and for all items in each period, and also the constraints about the capacities. And the second one is about the machine learning tool. For this tool, we first collect the data from the simulation and also the history data can be the input for this tool. Through this data, we can do the demand forecast and time uh, estimate to get the distribution of stochastic parameters. For the demand forecast is about the demand, and the time estimation is about the lead time and the production capacities. Mm. Through the through the uh, basic data such as bill of material and the resources and the cost, these basic data, we can get the generic mathematic model. And we use the distribution of stochastic parameters to create the customized mathematical model. And then we will use stochastic optimization method to get the production plan. Mm. And the third one is about the stochastic optimization approaches. These approaches for the multi-column, multi-item capacited load sizing problem with uncertainties is based on the dynamic, static, and dynamic framework. We will try to deal with large-scale instance. The instance will include 5 to 10 equivalents in the bill of material, and we will focus on a large planning horizon. For the middle term is about 1 year, and the long-term planning horizon is about 2 years. In the stochastic optimization approaches, the structure of the approach is the static dynamic environment. And first, we will create the mathematical model, and then we will try a fix and optimize algorithm. And we also want to try a hybrid heuristic algorithm based on the fix and optimize heuristic. And now we consider learning variable neighborhood search, constructive and local search methods, and the population based on mental heuristics. And then is a conclusion. What we have do is that first is the literature review on the digital twin simulation stochastic optimization for production. And then we give the digital twin driven integration scheme. And we also provide a generic load sizing model. Now we consider the fixed and optimized heuristic algorithm and the machine learning for the uncertainty forecast. We didn't finish this research now, and I want to introduce the future research about my thesis. First, we will evaluate the quality and the efficiency of the proposed method to deal with load sizing problem. And we will conduct and implement the tools in real factories. There are two use cases. One is the Siemens Energy, and another is the Atlas Copco. And then we will try to improve the heuristic algorithm and machine learning method for this problem. Finally, an interesting work direction is to study how to uh, maximize efficiency and minimize the complexity of the MRP system when we integrate it with other systems under uh, cyber physical system environment in Industry 4.0. And that's all my presentation. Thank you for your listening.